Hello, upper school. Hope everyone's doing okay. Shout out Steelers. Um, this video is going to go over the answers for exploration 2 of your textbook assignment, whether you did it online or on the packet. You can check your answers with this. Also, I'm going to be kind of talking about the content and just teaching. If you have any questions, send me a Jupyter message. Just a preview. We're probably going to be going more online through Google Classroom next week, so stay tuned for that. So here we go. So energy transfer is different than energy transformation, but we're going to start here that all forms of energy fall into two main categories: potential and kinetic energy. The position or condition of an object determines its potential energy. The speed and mass of an object determines its kinetic energy. A heavy object has greater kinetic energy than a lighter object, moving at the same speed. Likewise, an object moving more quickly has more kinetic energy than a slower object with the same mass. I think back to a bowling ball rolling down a lane. You know it has kinetic energy because it is moving. As the ball hits the pins, it slows. What happens to the kinetic energy of the bowling ball when it reaches the pins? So this ball does slow down when it hits these pins. What will happen if it rolls straight into an object with a greater mass than a bowling pin? So let's say that these aren't bowling pins anymore. Instead, it's a brick wall. What would happen? What you would think is the ball would hit the objects. In this case, it's a brick wall, and stop. It actually might start moving in the opposite direction. Okay, so this hands-on activity, we're going to try one of these eventually. Today is not that day. So we're going to skip over. Anytime you see this grid, don't worry about it. Energy transfer in collisions. So objects, going crazy. Objects that are not moving need energy to set them in motion. They carry that energy with them as they move. They can pass this kinetic energy to other objects when they collide. The passing of energy from one object to another is known as energy transfer. Because energy cannot be created or destroyed, you can model energy flowing through a system as inputs and outputs. Think about the bowling ball. It needed an input of energy from the bowler. The ball carried that energy as it rolled down the lane. When the ball collided with a pin, it transferred energy to the pin. Energy is transferred from the object with more kinetic energy. With more kinetic energy to one with less kinetic energy. The pin moves because energy was transferred to it. So again, energy moving, as soon as it hits the pin moves because I transferred that energy. Otherwise, the pin would stay put. Watch a video to observe. So these are colliding pendulums. Notice the one down here just stops. Interesting. Identify where the potential energy and kinetic energy of the swinging pendulum are greatest. So right here, the potential energy is the greatest before you let it go. And it's moving full speed here, so this is when it's greatest. Kinetic energy. So draw an arrow representing the transfer of energy between the two. So go here. So this, the energy is being transferred this way. That's why this goes up. I'll use a different color next time. So in a larger system, the kinetic energy in a pendulum collision from the moving of the pendulum is transferred to the motionless one. The transfer of kinetic energy causes the stationary pendulum to move to a position of greater potential energy that it had at its starting point. That system only had two pendulums. What happens when multiple objects are involved in a transfer of energy within a system? Consider a Newton's cradle, a series of identical pendulums hanging side by side. So let's check this one out, a little bit larger. So this one, actually the one on either side, move. So what we have to do is I'm gonna draw these like this. Okay, and then we need arrows. I gotta change my color this time. So the energy is transferring. Oh, I need a smaller arrow. Transferring this way. And that's why this one moves on the end. This one moves the most. This is the direction. But then it does come back the other way. A downward flow of water in a river is the result of the pull of gravity. As water moves downhill, its potential energy transforms into kinetic energy. This energy can be transferred to other objects as well, such as a raft floating down the river. The energy can also be used to do other work, as in a water wheel. A water wheel can be used to turn a grist mill, which uses the energy to grind grains for flour. A water wheel can also be used to power cranes. Cranes use energy from the water to lift and lower objects. This is a cool little diagram showing this spins the wheel, which spins this wheel, which spins this wheel, which turns a turbine and can transfer energy. You can get really clever with this stuff. Transfers of kinetic energy are used in devices and processes that reduce human effort. They may also improve efficiency. Energy transfer can also be used to do things that the human body alone would not be able to do. The raising of the obelisk in St. Peter's Square was made possible by the transfer of kinetic energy from many people and animals. Ancient Roman and medieval builders also used human-powered tread wheels to transfer energy. They could power cranes that were used to lift large stones to build temples, castles, and cathedrals. So we got this crank turning this, and this is a crane. There's also this idea of meteor deflection. Stony or metallic objects known as meteoroids often enter Earth's atmosphere. Most are small. They burn up before they reach Earth's surface. Rarely, large chunks traveling extremely high speeds hit Earth's surface. Because of their high speeds, the objects have a large amount of kinetic energy, such as impact can have disastrous results. In 1908, a 91 million kilogram space rock entered Earth's atmosphere above Tunguska, Siberia. The rock exploded in the sky, producing a fireball that destroyed 2,000 square kilometers of forest. A similar blast happened over another site in Russia in 2013, injuring 1,500 people and damaging thousands of buildings. I actually remember that. One idea for avoiding a catastrophe collision of space debris with Earth is using a missile-like projectiles to knock the object off its course. How can scientists be sure to create an impact with enough kinetic energy to change a meteoroid's course? What factors should they consider? Remember, two things affect kinetic energy: speed and size. So if it's 91 kilograms and I want to knock it off its course, I have to be going at the same speed as that meteoroid and be the same size. That's really hard to do. 91 million kilograms is really big. So what we would need to do is we would make something smaller that's going really, really fast. Projectile would be like a rocket. All right, so tomorrow we'll go over modeling energy transformations. And hopefully these are helpful. I'll keep doing them, even if one or two of you enjoy it. Try to spice them up a little bit in the future, but take care and let me know if you have questions on